the video, as you know, we always have a live ponage on Sunday Funday. Um, we're going to be poning the case for the soul, quantum biology, which I think is definitely going to be hilarious. I haven't watched it. In case people, and I'll open it up to the floor. My opinion of Inspiring Philosophy's videos is I really just don't watch them because I just kind of was like, that's time I could be doing other things because I think he's super repetitive and, quite frankly, just like annoying. I don't know what you guys think.
One in a week. Fun fact.
He's a propaganda artist. I mean, I hate going over to his page and just seeing stupid things that, he's just trying to brainwash people, and I don't understand that.
Yeah. And also we have Anti-Citizen X on his alternate account. Say hi to everyone. All right. So I don't know if there's any odds and ends that you guys wanted to talk about before we just start delving into this video.
Okay, maybe now you can hear me.
Oh, yes, we can hear you.
Yeah.
Oh, nice people.
All right. So
What are we watching?
we're watching Inspiring Philosophy.
Oh, the case for the soul. Oh dear.
Yeah, this should be interesting.
So I need to unplug my microphone so that we can pick up shit through my speakers.
I have like one more philosophy of mind video left, one or two, and then I'll be like moving on to other stuff. That was a good run, though.
Yeah, well, I mean, it's the thing with your philosophy of mind series is that they don't you have to imagine that these people just go out of their way to just not understanding things. Like on Anti-Citizen X's most recent video, animating rebel Santa, you saw this, animating rebel commented on the video like Frank Jackson's argument shows this, and I was like, you realize that he has rejected that argument since.
Yeah, why does he do that? That doesn't.
Because we have that screenshot of animating rebel saying he doesn't read philosophy. He agrees with it.
Oh my god.
Oh, yeah. Yeah, I saw that. That's very interesting. Andrew, did you really ban that guy for rejecting logic?
Yeah, had to be done.
That was hilarious.
That's the first person I banned, and I guess that's my rule. I'll only ban people if they do that.
They reject logic.
Yeah, I mean, you have to ban those people.
Guy left.
Yeah, I mean, it's really funny. And I like animating Rebel, though, because he's, very clearly the most arrogant of that group.
Yeah.
But, he has the least reason to be. At least, look, begrudgingly, I have some respect for D-Rest, because he did have to get to a decently high level of education. But, the amount of arrogance that goes with animating Rebel, he's as arrogant as D-Rest, if not more, and has way less of a reason. That's...
Yeah, because you read that thing in the first version of Andrew's video, right? All his posts and stuff. Oh my god, it was so stupid. He was blaming Ander and the realistic nihilist for not telling him that they made a video about him, even though he blocked them. You're just an idiot. Oh my god, it was dumb.
Yeah. Well, here, let's start with this IP taking a shit on logic. And as it is customary, I am disliking this video before watching it. I've never seen this video, I assure you. So here we go.
Are we slaves to the workings of the brain? Are we merely determined to our DNA?
Yes.
Okay, no one believes in genetic determinism. like IP, like that's not been a
Yeah.
mainstream idea.
Not racist. Hasn't that been like
What does it mean to be a slave to your brain? Like, you literally are your brain. Everything about you is contained in there. It's like saying, are we slaves to ourselves?
Yeah, it doesn't. Well, like, here's the thought
Who said
experiment.
that?
Right? IP. If I was to take your brain and like, if I was to create a complete molecular replica of you, like, if I like, let's say that like I have anti-citizen X, like I make a complete replica of him. Like every single synapse, every single chemical, every single everything is exactly the same. Is that going to be the exact same person? And I'm forced to think yes.
Wait, so does that mean I can clone souls? Or will I just create this lifeless hunk of meat that God will not infuse with a soul, and so it'll just like fall to the ground?
I don't
Yeah.
know. What does it even mean to like have a soul? Like Sam Harris goes into this argument. What even if you did have a soul, what extra gloss would it give you in terms of whether it's consciousness or free will? I mean, do they believe the soul is responsible for free will or consciousness or both?
I think they believe both.
That
Like point made so many times. It's just like pure vagueness. So Ander just wrote a comment in the side chat. Ander, I'm gonna read this. This is who would you say this is in the style of? I think it's sort of like a Lewis or a Tomas Cybertron.
The idealist, I don't know.
Curtis Page or something like that.
Oh, God.
The brain is a computer-generated representation of them made out units of quantum consciousness, in parentheses, information, which is measured by the soul's qualia.
That IP is actually going to get into that. Yeah, I think that's his position, which, I mean, we're going to see that's insane, but that's pretty much what they believe.
Well, yeah, but if you don't accept that position, I mean, that just means you're a logical positivist, right?
Yeah, well, I like how he's like. The funny thing about these people is they're so like philosophically illiterate. Like, by no means am I like a philosophy major. Like, I barely took any philosophy in college. Like, but I read a decent amount. But I'm by no means an expert. But even I know that like modern forms of logical positivism have solved a lot of the problems that he mentions. Like.
They just reject that out of hand. The moment you say positivism, they're like, oh, that fell out of fashion. Nobody thinks that.
As they're idealists, though. Like,
Totally.
Well, I mean, to be fair, logical positivism did kind of go away. I mean, there's sort of a resurrected version of it that's more cogent, but the sort of Vienna Circle is not really.
But my point is they're talking.
Yeah, it was like a social club.
But like they're making fun of a stance that none of us actually hold anymore, right? Like the modern sort of empiricist point of view, which, and by empiricism I mean like the old school like divide between do you believe that most knowledge comes from experience and data, or do you believe that most knowledge comes from, you know, just reason and logic, you know, a priori versus a posteriori. Like, it's mainstream to fall on the a posteriori, the empiricist point of view that we all do, but they just kind of disregard that so that they can just shuffle in their bullshit, right? It's just word game.
Yeah.
All right, let's continue.
For years, many scientists thought we were determined and completely created by our DNA and brain biology. However, a new field of research has challenged these established beliefs.
Who has ever said we're completely determined by like our DNA?
yeah.
There's also environmental and
It's like
social.
it's a very like 1960s idea, right? Like,
Isn't it
like-
racist also, kind of? Didn't scientific racists also have this sort of idea?
yeah.
You are your DNA and nothing else.
Well, genetic determinism in general was a very popular view held by scientific racism.
It's, well, I mean, like, we didn't. Here's the thing, right? Is like, it's never, even the most genetically deterministic people, like, were not as, like, they weren't, that wasn't even complete genetic determinism, because when you look at the original equations for heritability of traits, those were laid out in, like, the 1930s. and there's there's a term for the amount of variance in a trait that can be explained by the environment. So like it's been acknowledged for 75 years, 80 years that like the environment has a major contribution to how traits go. Like it's just a basic fact that if the cell needs nutrients, obviously the environment is an impact. But you're also expecting someone like IP to have literacy in a scientific topic. Let's go.
Biological robots. The field of quantum biology has begun. Some researchers have been arguing for more than a decade now that quantum biology gives us a more complete description of ourselves. To start, quantum biology is the field that applies quantum mechanics to biological systems in order to explain how they operate, where classical biology cannot give a full account.
What does this have to do with the soul?
He's gonna get into that, but
I guess let's continue.
It's really a stretch. This is like him patting himself with techno babble. Like, it really was no point that he had to give us this terminology. He just likes saying quantum a lot at every chance he can get.
Yeah, I get that sense as well, because like you learn, like you can model so much, you can describe so much of biology in classical terms. You don't, I mean, like I think quantum biology helps with like, it seems like it just helps with like edge cases, where it's like this, the kinetics of this reaction don't really make sense. Oh, look, it's a quantum weirdness effect, right? Like that seems to be, like I know with photosynthesis, part of the mechanism of photosynthesis
is with electrons and things like that. Now they get absorbed.
Well, on that sense, everything is quantum mechanics, because we're all made of atoms, and atoms are quantum mechanical. And
depending on the level at which you analyze it, though, that's the thing. I mean, reductionism doesn't work if you're searching for a particular thing or trying to solve a particular problem. You have to analyze it on the appropriate level. Otherwise, it doesn't make any sense. So, biology, you're dealing with proteins, macromolecules, lipids, and whatever. I mean, chemistry would be good, but I mean, going into the quantum, I don't know. I think that would be good for biochemistry, but
yeah, I mean, it's like I don't know why he's making such a big deal, because like the vast majority of biology just has no use for quantum mechanics, and that's not denigrating quantum mechanics. Again, it's like it's just a fact, right? That like our classical predictions and explanations, they work, right? Like we can describe how a transcription factor binds without, alluding to quantum mechanical processes, because, they're big enough and it's a warm enough system that you don't need it. And maybe, maybe a complete biophysical picture of the cell requires some quantum mechanics. But again, I don't see where the soul gets injected. You know what I mean?
Well, in his defense, if you Google quantum biology, there's apparently like textbooks and things written about it, and actual courses you can take at university level. But really, just reading some of this stuff, all it is they're just doing chemistry and explaining certain bits of chemistry by quantum mechanical processes.
Well, I mean,
you have to if you really want to get down to the nitty-gritties of physical chemistry.
Well, yeah, and there's also the he's going to bring up the bird's ability to sense magnetic fields as being, a quantum process, which I guess it is, but I don't see what that has to do with the soul.
You can do that with any process at all that involves atoms. There's quantum mechanics buried in there somewhere, so it's really not special to say quantum mechanics is involved with blankety blank, because you can stretch that expression to mean anything and apply it to everything. I mean, I took a shit the other day, and you know what? There were atoms in my shit, and they had solutions to the Schrodinger equation involved in there somewhere with the eigenvalues of the electron wave functions and bonding my crap together. Is there quantum shit now? Quantum turdology? Or what? So that's why this idea of quantum biology is just, he's really like grasping at a straw here to use this kind of term. It's just glorified chemistry.
Yeah, I'm looking at like one of the articles that he linked, and it's talking about a mechanism of mutation. Part of it being the fact that like there are what they're calling quantum jitters in DNA.
Yeah, that Duke article, right? Yeah.
I mean, okay, that's. I mean, maybe that's. I mean, we do also know how different types of stress cause damage in DNA. So I mean, like, again, at what level is he overblowing this? And
Has that even been accepted into the mainstream? See, this is what's. I mean, a lot of times you just because you have a publication doesn't mean that, you know, it's automatically going to be particularly incorporated into like mainstream textbooks. It takes a while for that sort of discovery to be established.
I mean,
So-
I'll grant that it's mainstream, but it's not going to be the main. Like, we know some of the mechanisms of how these things work. Like we understand how these things work a lot of the times. Like, we don't. There's no need to. There's no need to invoke this quantum magicness. Like, but I don't know. I haven't watched it in full, so let's continue.
Shown to play a role in photosynthesis and how birds migrate, as well as how our sense of smell works. Quantum entanglement has been shown to hold together DNA, the code of life itself. And within DNA, there is evidence that quantum jitters, random instantaneous changes, could be causing genetic changes and be a driving force for evolution. Duke researchers.
Yeah. So this is kind of bullshit, and it's overhyped, I have to say, because all they're doing is introducing a new mechanism for mutation. But like, we already know what. Like, there are people who actually work on how do you predict the mutational landscape, and they can do it with stunning resolution. And you want to know what they don't use?
What? What don't they use?
Quantum jitters. You can explain 85% of the variance in different cancer mutation landscapes using the epigenetic features of cells, right? So basically, the way that the DNA is oriented in a given cell, when certain genes replicate, stuff like this drives how mutation happens, for the most part. And granted, that's not 100% of the variance. It's like 85%. That's a huge amount of explanation.
Again, any classical phenomenon can be described in quantum mechanical terms. So saying quantum X is totally meaningless
Wait a minute.
unless you're just trying to brag about how sophisticated and gee whiz you are because you threw the word quantum into it.
Wait.
In real life, we go out of our way to avoid using quantum mechanics at every turn because it's hard to do.
Yeah. Reading from the article linked in the video, it says, quote, now Duke researchers have witnessed DNA bases making the slightest of changes, shifting a single atom from one spot to another, or simply getting rid of it altogether to temporarily mimic the shape of a different base.
So what?
not-
That's chemistry.
It
The atom is just not quite where it should have been, and so chemistry happens. So what?
Yeah, and keep in mind that, you know, at the 4 nucleotide bases, you know, adenine, guanine, cytosine, thymine, those are compounds. But that doesn't. The fact that one atom is moving from one place to another at a statistically rare rate doesn't mean anything, because we're talking about entire compounds. I mean, you would need an entire diffusion of atoms going all over the place in order for your DNA to change that much. Although, I mean, it could have an effect of a mutation, but I mean, it's not the sort of thing that IP is imagining.
Again, like, this is not complicated stuff. He's just complicating the obvious. It's obvious the world is made up of atoms, and chemistry is what happens when atoms bump into each other, and quantum mechanics drives that process. So of course, on the biomolecular level, quantum mechanics is going to just be involved there. So what? But he's talking about this like this is like super duper amazing. No.
How
Atoms
much of this
are
is
governed by chemistry.
like how much? Like I'm looking through some of his references. How much of this just boils down to like a lot of it is just, oh, these are really small molecules, and like these are really small molecules, and this is stuff happening quickly on a small time scale. How much of it is it just, well, we need quantum predictions on this time and length scale?
Let me just read this paragraph from the article. It says, this tiny movement or quantum jitter takes such an enormous amount of energy that bases are successful at accomplishing the feat only once out of every 10,000 or so attempts. Even then, they can only hold their new shape for a very short period of time, 50 to 200 microseconds, that's 1/1,000,000th of a second, 50 to 200 millionths of a second before the hydrogens pop back into their original position. So it's something that happens very quickly, but it's not permanent. So the effects aren't necessarily permanent.
And he said in that video that it's a driving force for evolution, which, if we're going to go by the information that you guys are saying, that seems like an insane amount of exaggeration that he's bringing on. An insane amount.
There's a lot of work that's been done on, how can we predict where mutations happen? And look, I mean, I have no doubt that this quantum stuff would help us predict this. I have I don't know why I'm supposed to have a reflexive reaction. It's like, cool, you're using physics to describe a biochemical system. Right.
Yeah, that's a good point. He's using the word quantum in a way that's designed to make you go, ooh, quantum.
Well, yeah, but that's like the apologist game, right? I mean, they're obscurantists and they try to look really smart, but when you actually look into what they're saying, it's just sophistry.
Mm-hmm.
All right, let's continue with this and see what else is going on.
They found what they call quantum jitters in the shapes of DNA bases that may account for the spontaneous mutations driving both evolution and disease.
It was once believed quantum mechanics played no role in macro objects, let alone biological structure, because the environment is too hazardous for quantum processes. Yet this...
Did you hear what he just said? The environment is too hazardous for quantum processes.
What?
Quantum processes are so safety-oriented.
Everything is made of atoms, therefore everything is governed by quantum mechanics. I really don't understand why he thinks this is a poignant thing to say.
Well, he thinks that the effects, like the very weird effects, can scale up. That's the issue, and the objection is that thermodynamic irreversibility and other, products, the heat, the concept. If you take a statistical physics class, you'll learn about the concept of a heat bath. Everything averages out once you get into the large scale. I mean, if you try to, because wave functions, you can try to model the movement of a harmonic oscillator, a 1 kilogram harmonic oscillator, using, the Schrödinger equation. You could actually, I mean, if you have a very powerful enough computer, you can actually model that equation, but you don't use that model anymore because it doesn't, it's not that it doesn't work, it's just that it's not necessary. You can just use classical physics.
Well, yeah, a lot of quantum mechanics just converges the classical mechanics on a large scale, so what? It doesn't mean that quantum mechanics just isn't there anymore. It just means it converges into simpler equations for describing it.
And the effects
we can do.
Yeah, and the effects go away. So this phone that I'm holding is not going to tunnel through my house.
All right.
All right, let's continue.
Nobody really assumed quantum mechanics just disappeared entirely, or it's the fundamental stuff that governs the atoms that make up everything.
Yeah.
So anyway.
Research alone refutes this claim. It is now known biological systems can and do take advantage of quantum processes and can use them for beneficial means. But can this be applied to the brain? Can aspects of quantum biology better explain how the brain works and how the mind or soul is able to work with the brain?
What does the soul have to... he keeps using this word for no reason.
Yeah, he's kind of begging the question. He just snuck that in there. Oh, yeah, the mind or the soul. Wait a minute. When did we establish that there was a soul?
Well, that's the case with the soul.
I think you would say, watch my other videos, basically.
You know those articles that he was referencing. I'm almost willing to bet he didn't read anything past the abstract.
Well, most of them have paywalls, and I don't think he's at a university. So, I mean, let's give him the benefit of the doubt. Let's say that Derez, masturbated to his voice when he made the request, and then downloaded the PDF, and then sent it to him over Skype. Which is good for IP because Derez would have gotten, like, he's not a very bright guy, so he would have used the paper that he printed out as cleanup. You know how he is. Let's continue.
Quantum processes exist and are used in biological systems. There is no reason at face value to assume they could not work in the brain. On top of this, there's actually new research.
What does that statement mean?
Argument from ignorance, right there.
Quantum mechanics goes away because your brain isn't made of atoms? Like he's stating like very vacuous truths. I don't trivially true.
God performs miracles, so quantum mechanics goes away.
Wait,
Yeah.
That's why gravity is not reducible.
Isn't he also committing the argument from ignorance when he says, well, because we know it happens on some biological processes, that means we can't obviously know the brain, but there's no reason to think it can't happen.
Well, he gets into it. He explains how, there's this weird benzene ring thingy where it resonates and forms a qubit and blah, blah, blah. So he's going to justify that.
I should note that this study that he's referencing wasn't performed in vivo. Like, it's not a live brain. They isolated some microtubules and then did the experiment. Like, I've read the paper. Like, even if I grant it, there's no reason why this actually would have a brain-wide process when you're only showing that it can happen
within a very small part of the brain, like a microtubule.
Well, I mean, it's a subcellular structure.
Yeah.
Like, let's see what he says. Santa, what are you doing right now?
I'm just, like, going through comment sections, like, trying to understand.
It sounds like you're twisting something to death.
Oh, I'm sorry. It might be because I'm using headphones. I'll stop.
Okay,
I'll take it out.
No worries. So let's continue.
It is more compatible with our intuition and how we assume the brain works. In reality, quantum mind theory is really a collection of different theories. However,
yeah, what predictions does that theory make?
Quantum mind theory? I'm going to Google this right now. Quantum mind theory.
It's a form of physicalism.
I have to just, as a side note, I have to say I was listening to some talks from some philosophy of mind lectures, and Stuart Hameroff is literally the worst thing that ever happened to philosophy of mind, quantum mechanics, and biology combined. I mean, that guy is just an irritant. It was just... He, in front of a large crowd, or a large group of people, he asked, what's his name? David Rosenthal. He's this other guy that, he gives, he's an expert in this field. He's a philosopher. If polypsychism was proven, how would that change your mind? Like, in all seriousness, he asked if polypsychism is the view that there are many souls in one body. He's like, how would that change your theory? And the guy was just like, what the hell are you talking about?
All right, let's continue. This is going to be interesting.
They all argue aspects of quantum mechanics, like superpositions and entanglement, play an intricate part in the brain and how we process information and make decisions. Most of the theories revolve around the basic premise that deep inside neurons, there are tiny structures called microtubules, which are made of proteins called tubulins. Since tubulins are proteins, they contain amino acids called tryptophan.
Correct.
On a molecular level...
IP. Not every protein has tryptophan in it.
Turkey has tryptophan.
Everything, tryptophan's a very common amino acid, but, like, you can't... Just don't make statements like that. Like...
Now here's a question. Everything he's about to say is true for any mammalian brain or reptile brain or bird brain. So The
Why do
only
we
way
have
we
to
can
have
extend
the
this is that everything with a nervous system has a soul.
Also, like, again, like, if we want to talk about things that have a horrible track record of predicting how the human mind works, it's single neuron level things, right? It's more, the brain is more about how things are wired together than the fact that things are wired. Does that make sense, right?
Yeah, that's why I keep going on about like conceptual frameworks and how they can embed themselves in your brain and the associations that you make, because that's how we do think we learn. I mean, this is like machine learning, basically. That's how you're able to integrate the information you receive from your environment, and
I'm
like
very confident I will never learn how to speak Chinese because it's so insanely difficult because my brain is just not wired to process that type of language structure. So it's not an issue of where, like, oh, I have defective neurons. It's the fact that the pattern in which my neurons, like, grew and have been pruned and adjusted they're at it's in such a way that it makes it difficult, which it makes sense. That's why kids are better at learning language than adults.
exactly. I mean, this I don't know how.
Let's continue.
Let's hear what he has to say.
Oh, sorry, what were you saying?
Let's hear what he has to say here.
Oh, okay.
Carbons bound together in a form of a ring. This ring consists of electrons that oscillate from side to side of the ring. Because of the uncertainty principle of quantum mechanics, the actual location of these electrons is more properly described by a wave function.
Correct.
It's a cloud of possible locations. Because these...
Well, I'm pretty sure that's not how aromaticity works. So what he's describing is the fact that when you look at this hexagon structure, I don't know if you can see my pointer.
Yeah.
Right? You have alternating bonds. And so you have sigma and pi bonds.
Yep.
Sigma bonds are usually the primary bonds that are used to form like a single bond, whereas a pi bond is the next like electron. I don't know, that's an orbital space or something like that.
An orbital space, yeah.
Yeah, it's an orbital space where they form another bond on top of it, you know, a double or a triple bond, right?
Yeah.
What happens in an aromatic structure, and this is the reason why benzene is so weirdly stable, even though it's just a carbon structure, and this would loosely be a benzene ring if it was just the hexagon, is because with the way that these bonds are set up, it's not actually a static structure. The orbital is constantly being shared throughout all of the electrons, and so you have this weird sharing of pi bonds across all 6 carbons in this what's called a resonance structure.
Yeah, we learned this in chemistry, and then we did some of this in solid-state physics. Kind of crazy.
How much of this? I don't know how much of this is due to the. How much of this is due to like he's saying it's due to the uncertainty principle. I don't know enough of the quantum mechanics.
Well, see, you can have structures like these that can have their electrons be transferred from one part of the structure to another part. In fact, this is how you can get polymers to conduct current, is by this sort of rapid transfer of electrons. I don't know if that's necessarily due to the uncertainty principle either, or some other sort of property that allows them to do this, because they do it very well.
So I'm trying to look. I'm on the aromaticity Wikipedia page. So there's only one thing I'm looking at. So yeah, I mean this is basically this is the an aromatic compound contains a set of covalently bound atoms with specific characteristics. One, a delocalized conjugated pi system, most commonly in the arrangement of alternating single or double bonds, alternating single and double bonds like I described. Coplanar structure with all of the atoms in the same plane, contributing atoms arranged in one or more rings, a number of pi delocalized electrons that is even but not a multiple of 4, etc., etc., etc. But I'm not seeing anything about like uncertainty principle or anything like this.
I think. Wait, you said something about delocalization? of electrons?
Yeah, it's a delocalized conjugated pi system.
That might be what contributes to the fact that things like this can conduct current, but
like again, I'm operating off of organic chemistry knowledge here, but like I don't remember the key aspect of the behavior being quantum mechanical. So that's why I'm sure at a certain level, Antithesis and X said, it's everything is quantum, right? On a level. So of course, quantum mechanics would contribute to it.
yeah. Okay, so here's what it says on the Wikipedia article on conductive polymers. Here's just one paragraph. While mostly operating in the quantum realm of less than 100 nanometers, molecular electronic processes can collectively manifest on a macro scale. Examples include quantum tunneling, negative resistance, phonon-assisted hopping, and polaron. In 1977, Alan J. Heeger and Alan McDiarmid and Hideki Shirakawa reported similar high conductivity in oxidized iodine-doped polyacetylene, which polyacetylene is a very strong and very well-known conductive polymer. For this research, they were awarded the 2000 Nobel Prize in Chemistry and things like that. So, I mean, you can have these sort of effects of hopping from one branch to another and things like that that changes the conductivity of the polymer. Charge transfer complexes are what they're called.
I mean, I think the moral of the story is that there's zero chance that IP put this type of work into actually understanding what's going on, because the way that he's explaining it is just quantum, quantum, quantum.
Oh yeah, it's not about the uncertainty principle. I'm reading it. It's not about the uncertainty principle. It's about having to do with
Well, it's the fact that the sigma bonds share electrons. And so
and they're transferred between the two molecules, and I think it's due to electrostatic attraction, is what it says.
Yeah, well, it's basically, I mean, the way that I learned it is that it's basically that all of the bonds are in the same space, and so what's happening is they're overlapping, and when they overlap, it's because the electrons are being shared, and because of the structure because of the resonance structure, they're shared across those bonds.
Yeah.
And like, I don't know what that is. Like, again, it's partially like I don't know quantum mechanics very well, so
there's nothing here about the Heisenberg uncertainty principle at all. It's not even, I mean, that if you want to be redundant and say that, the Heisenberg uncertainty principle explains the electronic cloud, then okay, but I mean, big deal. It's not anything controversial or anything special.
Let's continue.
Tryptophan molecules are close to each other. One tryptophan ring can share an electron cloud with another tryptophan ring, and so on and so on. Sharing of the electron clouds causes the displacement of the tryptophan into a superposition of two states. So due to the molecular makeup of tubulins, they can exist in a superposition of two states at the same time, which we'll represent as a 1 and a 0. Now, being in a superposition, it would exist as both the state of a 1 and a 0.
Okay, let's stop this right now.
Qubit.
Literally every particle in quantum mechanics can be in a superposition with itself in its own eigenvalue states. So this is like something he's sort of saying that's trivially true. It applies to everything. So I really don't understand why this is supposed to be incredibly amazing to me. A single electron around a hydrogen, a proton, can be in a superposition of two eigenstates. So what? A single electron can have spin up or spin down, which is a superposition of states. Whoop-de-freaking-do. So I really don't see how this is at all significant, other than the fact that it's happening in your brain somewhere, as opposed to everywhere else in the universe.
But here's even the thing, right? Is microtubules are ubiquitous. Like, they're expressed globally. They're one of the biggest constituents of the cytoskeleton. Like, I don't know, like, why is the brain conscious on this theory?
Because your homunculus soul is hiding inside your brain and triggering neurons to collapse. That's kind of where he's going with this.
How do neurons don't collapse though?
Their wave functions are going to collapse because the soul reaches out and touches them. That's essentially where he's going with this. You have
Yeah.
a soul inside your brain that touches neural synapses and causes superimposed states to collapse into distinct states. That's where he's going with this. Just watch.
Collapses to one state or the other. Now, since tubulins make up microtubules, the sharing of the superposition along an electron cloud can exist along several different pathways, which is known as a topological qubit. Thus, through the different possibilities of just one microtubule, different pathways could exist in a superposition, and this results in large-scale coherence among thousands of tryptophan molecules on any given microtubule. The two requirements for quantum computation
Again, so what?
are positions of two states, which
You
allows
can get
molecules
massive scale coherence in any solid-state material. Your aluminum soda can, more or less, kind of does what he's saying here, just by virtue of all those covalent metallic bonds. So what?
And I'm also like, I'm gonna VP, like, here's the thing, IP, is like I have access to a university server, so I'm actually gonna look at this, at one of these articles, because I just have a feeling that this topological qubit nonsense doesn't appear, it doesn't appear in the article that he cited.
Also,
I did a control F for topological.
Can you hear me?
Yeah.
Yes.
Okay. I think based on what he's showing right now, superimposed tryptophan. I just came in high. I think he's going for orchestrated objective reduction.
Yes.
That sounds like, and I mean, I already have the paper pulled up that destroys that.
I mean, we're talking about a theory that just isn't
It's not viable.
taken seriously.
We're talking about a theory peddled by a guy who would ask at a conference about the possibility of multiple souls existing in one body.
So this topological qubit nonsense, and I say nonsense because I'm looking at the article that he cited, and the word topological doesn't appear in any of the two articles that he's looking at for this microtubule behavior.
Those
And again, what IP, I have to ask, if this is the case, why, what is happening when cells divide? Because I don't know if you guys know this, when a cell divides, you know how the DNA duplicates and then it gets pulled apart by the mitotic spindle?
That's the metaphase, right?
I believe it gets pulled apart during anaphase. Is when it starts getting pulled apart. But yeah. So you're following, right? Those are microtubules that are pulling it apart. So what the fuck's going on a conscious level there? Like, why is that like some weirdly like orchestrated consciousness?
Well, see, the thing is, your cells also multiply whenever you memories form by the multiplication of cells. I'm pretty sure. I think they've seen memories.
So we don't know. Like there are. So here's the thing: on like a cellular level, we don't know exactly how memories form. Like
it seems to be strengthening of like, in quotes, strengthening of like synaptic currents basically in like, hippocampus and shit. And then as for
expression
of cells, I'm not sure.
And there's a gene called CAM2 kinase that when you knock it out in mice, they have like no memory.
Is that how they created false memories in mice?
I believe it does something where, I mean, this is from a while ago, but it does something to disrupt it. Then there's evidence from like primordial, like, I don't want to say primordial, but lower level organisms that can sort of like, they have memory type behaviors, and that's from protein aggregates. So that's a proposed mechanism, is that you have some level of protein aggregation, but that can go out of control when you get, Alzheimer's. Like, like, again, we're talking about, and granted, I'm not a neuroscientist, but like, we had a guy, my intro biology teacher, one of them, because we had a bunch for the different units. He does learning and memory in songbirds, which are like classic model systems for memory formation. And he basically said that we don't really know how long-term. Like, I asked him this question. Now, this was years ago, like 6, 7 years ago, but I asked him this question, and he basically said, well, we don't really know. It has something to do with long-term potentiation and, you know, gene expression in the hippocampus, but we can't really be sure.
Yeah, I don't think it's changed much since then.
All right, let's continue here. But the point being that these articles don't mention what IP's talking about, so I don't know where he's getting this nonsense from.
Do the articles even mention qubits?
I just closed them. Let me reopen them in my other window.
I know this is like the $1 million question, but what does this have to do with the soul? Like, I just don't understand.
No, they don't have qubit. They don't have. Neither of them have qubits in the article.
So he just made up a bunch of bullshit then.
I'm gonna see if they have anything about.
He pretty much Googled quantum biology, brain, and neuron, and just cited whatever came up in his Google search. That's what it seems like.
I'm also looking for computer, and like there's some stuff about how they're trying in their references in the reference section about like stuff like how can we construct a computer that uses the principles of biology, but that's not. Again, that's not like as someone with a computer science degree, that's nothing new. Like we do, like that's how machine learning works, right? We're constructing models that attempt to learn like the way that humans learn, and like we're doing like the reason why text to speech works so well is because it operates off of the principle of training in the same way that we train a child to learn a language by only isolating relevant features. We do the exact we tell the computer to do this, but with a much more sophisticated mathematical model.
Yeah, that's why all my stuff regarding philosophy of mind has been sort of an externalist approach, rather than explaining it from the inside. I think that a lot of it has to do with, you know, training from the outside. But I mean, this is problematic for someone like IP because he cannot grant that there is sort of an outside influence on the mind that gives it consciousness or qualia or subjective experience. He thinks it's all something that's sort of going on from the inside, and it all happens from the inside. And that's what you're seeing here.
Oh, so there is one article that he cites that does mention like how you can basically abstract these proteins into memory bits, sort of like flash memory. I don't really know that it seems a lot like what Anti-Citizen X described, which was, oh wow, things have states. So I've linked that in the side chat if you want to take a look.
But yeah, even though these superpositions happen, they don't happen for long enough in our actual brain to do anything really. So I don't know.
Well, it doesn't matter if they do anything or not. They're just totally non sequitur disconnected from souls.
Yeah,
I mean, physics he's talking about here. Even if we grant the whole thing, it's like, okay, there's atoms in my brain doing shit. Okay. Where's the soul you speak of now?
I don't know. I kind of just reduced what he's talking to quantum, like quantum consciousness in my head, and started like going after that instead. So.
Yeah, I'm not like a lot of the stuff. Like at the end of the article. Like I mean I don't know how big of a journal Applied Physics Letters is. Like they're
pretty
like
good. I would say.
Like they're trying to.
They isolated a single microtubule.
Yeah, they're isolating a microtubule. Like again, this isn't something that's actually happening in the brain in this paper. So like basically what they're saying is if you the gist that I get from this, and granted I'm a complete layman when it comes to quantum computing, is that if you isolate a microtubule and you apply a charge across it, like a voltage across it, it can behave like basically they said 5 bits, which I don't know that like again, like they don't mention topological qubits or
They said
like
500 distinct bits with 2 picoamp resolution between 1 nanoamp and 1 picoamp.
yeah, I don't know how this justifies what he's saying. But let's continue.
To represent qubits, we have seen how this could occur in just one tryptophan molecule, which when displaced exists as a superposition of a 1 and a 0 state. The second requirement is large-scale coherence. Again, we have seen how this occurs among thousands of molecules at the same time.
But we haven't. None of this actually says that there's topological qubits. Like I'm looking at the paper right now that he's referencing.
I think he's just talking about some superposition of states rather than being between spin or eigenstates. They're just arranged in space differently. I don't.
This isn't topological.
Explain what that is. It just threw out a big, complicated word and expects you to go ooh again.
Isn't a topological qubit just like a two-dimensional like quasi-particle?
Yeah, it's a theoretical quantum computer that employs two-dimensional quasi-particles called anions, A-N-Y-O-N-S, whose world lines, oh my god, this is where you get into like relativity, crossover and form braids in a three-dimensional space-time. And these braids form the logic gates that make up a quantum computer. This is entirely theoretical physics, and then you get into computations and error correction and control.
So why is he? So from what you're saying, this is entirely that thing.
This is a theoretical quantum.
It's not mentioned in the articles that he's citing.
Yeah, it's entirely theoretical if it's what I'm thinking of. Like, it hasn't even been like attempted.
Yeah, it says, like, the last paragraph, while elements of a topological quantum computer originate in a purely mathematical realm, experiments in fractional quantum Hall systems, this is like semiconductor physics, indicate that these elements may be created in the real world using semiconductors made of gallium arsenide at the temperature of near absolute zero and subjected to small, magnetic fields. This is where you get into, like, really high conductivity. You can vary the conductivity of a particular semiconductor with temperature, and then you can sort of explore their effects there. But, I mean, we're talking about, if you want to talk about quantum computers, the conditions necessary for this would be near absolute zero, which is nothing like what the brain is like.
All right, let's continue. The one thing that I want to briefly point out is that, do you think that IP looked into it with as much critical skepticism as we are right now?
Absolutely not.
Probably had a spoon-fed him from rats or something.
Yeah, rats is just, he's
special.
Yeah, he just got it from somewhere and just probably pasted it out thinking, hey, it sounds good. It seems like it would convince
Well, I think he actually
me to go with it.
It seems like he's not anybody in particular. It seems like Inspiring Philosophy just found like some quack Woo article and just started fucking talking about it.
Well, I think
you also get the sense that what he'll do is he'll find an article that has his conclusion and then just go through the references and then just link the references. Like, do you notice that about all of the articles that he seems to link in all of his little things? Like, they're not very systematic, his reference section.
Yeah.
Not that they need to be. Like, this is YouTube, but, like, when I link shit, I always say, this is why I linked this, like, either in the video or, like, in the description bar I describe what they are. But let's continue here.
Yeah.
And because microtubules are so close to each other in the human brain, large-scale quantum coherence could be shared between thousands of microtubules. Thus, microtubules inside neurons fulfill the two requirements necessary for quantum computation. I know this is a little complex, but what this would mean is the brain could compute different possibilities simultaneously.
But why would it be the brain? Microtubules are like ubiquitously expressed. They're a constituent unit of the cytoskeleton.
Of any cell, is that right?
Yeah, they're what gives your cell like its shape.
So
This is also true for crickets and spiders and frogs.
Wait, do skin cells have microtubules?
Yeah.
Yes, every cell has microtubules.
Okay.
Your skin is fucking conscious. There you go.
Yeah. I'm trying to like look at like where it's, or like I'm trying to see where exactly it's.
Hey Sam.
Huh?
So are microtubules, are they in just neurons, or are they pretty much ubiquitous in any living biological thing? Is this true for anything with a nervous system, or like do sponges have souls now?
Like I mean, there are. So here's the thing, right? Is like, there are some tubulins that are like. I'll grant him this, that like there are some tubulins that are tissue specific, but like here I'll screen share another window that I have open. So here's the Wikipedia tubulin page.
Uh-huh.
And what you'll see there is, okay, that's tubulin in the beta tubulin in Tetrahymena. Tetrahymena is a protozoan.
So what? E. coli has a soul now? There's quantum computing going on and everything.
So I don't know that tubulins are expressed. They're like the tubulin domain is like. So I'm looking at this right now. There are analogs to tubulins in bacteria. Like it's a very well-known evolutionarily conserved protein domain.
Okay. So literally everything has
look like where I used to know like where it's expressed. So tubulin domain. I'm looking at the European Bioinformatics Institute. So here are some of the species: Homo sapiens, Daniorario, which is I'll just read the name of the species: zebrafish, rice, mice, mouse ear crest, which is Arabidopsis, it's a plant, fruit flies, nematodes, baker's yeast, fission yeast, and E. coli.
So my dinner is quantumly computing.
My bread
These are species that have the tubulin domain in it.
All right.
Is our tubulin domain the same as other tubulin domains, or is there a special one for humans?
I mean, each species, I think, tends to have their own tubulins, and some of the tubulins can be tissue specific, but like the domain is very well conserved.
Well, IP is giving you the impression that this is only happening in like human brains.
Exactly. I don't know why I didn't come up with that objection, because I mean, your bread is conscious, according to
It's going on in like every living thing, apparently. If we stretch the analogy just a little bit, or I don't know, like, what's the difference between a frog's nervous system and mine?
But it seems as long as you use quantum mechanics, you can pretty much rationalize everything. You can just simply say, oh, but it is specific to the human brain because quantum reasons.
Because quantum, yes.
Quantum
Frogs
logic.
are governed entirely by classical mechanics then.
100%.
So like I'm trying to find, I'm forgetting. Okay, tissue specificity. Okay, so this one isotype, which is tubulin beta 1, it's expressed almost exclusively in leukocytes, which are immune cells. So it's only in blood cells is beta 1. So does that mean that our immune system is conscious? I mean, I guess that's how they identify all the diseases, you know?
Wait, can I say something about this? This is interesting. You guys happen to be talking about this. Have you ever watched under 300, 400 times magnification the behavior of single-celled eukaryotes, which is all multi-celled creatures are this kind of cell? So amoeba and paramecium, they escape. They behave. They chase things. They know that they've gotten trapped, and they react as if. So I don't understand why behavior like that. Why would behavior like that be anything other than sort of emotional, feeling-based stuff? And yeah, be some sort of dim consciousness. I don't know why it wouldn't be. Or for that matter, when we didn't have such good magnification, how we saw these little bits of things moving in the pond water and realized they were alive and distinguished them from bits of thread or whatever. No, we could tell when something's alive. What are we noticing? There seems to be a computational, sure behavior. There sure isn't a Turing machine. So it's not just saying quantum mechanics is weird and consciousness is weird. It's like, of course, we can't explain consciousness with Newtonian mechanics, which we now know is incomplete. Why wouldn't we use the state-of-the-art physics to explain this machine, basically?
Well, you said a lot of things there that I don't necessarily agree with. The first is that we understand a lot of like the chemosensory reactions of single-celled organisms. I mean, what they're doing is more akin to what our immune cells do when a trauma is triggered, and it's just the human mind is very good at attributing agency to things, when in reality it's, a lot of the chemistry is very similar in that it's just chemoattractive and chemorepellent forces.
Well, wait a second. We could tell which things were alive, and by that we meant had agency of some sort, before we knew there was even a genetic relationship. So some people might want to do that in ordinary, just folk, history. But the scientists, when they're getting careful telling which was alive and which had agency and which didn't, they got it right. There was nothing called alive that isn't alive.
Things that are alive behave fundamentally different than things that, when we talk about life, things that are alive act in something that's different than inanimate things. So I'm not surprised that they're able to identify it. I just don't know why that's evidence of like a primordial consciousness. That just seems like a non sequitur, because when we talk about consciousness, we're talking about something that advanced nervous systems do.
But you don't. Why do you say that? Where is the distinction of advanced nervous systems behaviorally? If you're trying to decide what is conscious and what isn't, you do it by behavior in all but your own case. So you'd have to describe what that behavior is. And you can easily watch white blood cells.
The way that these primordial things react is just simply chemoattraction and chemorepulsion. And like you can say, oh, it looked like something, but they've done these simulations where if you have a little pointer with an arrow and you have it moving in certain patterns, and it can be just completely randomized on a computer. They do this all the time. People will attribute emotions and motives to something that's a complete random simulation. So
not scientific researchers don't have that history. There was no natural phenomena that got misidentified as alive.
Well, that's because we can characterize life in a different way. Again, you're attributing something that, I don't see why we need to say that these things are conscious.
But why do you need to not say it? We have to suppose even whether other human beings are conscious based on what sounds reasonable. And why would you assume they weren't? They have the same...
I'm not assuming. I understand the biochemistry behind why they're not.
And their cognitive
capacity. You think you understand the biochemistry of what makes something living or not?
To a certain degree, yes.
And you understand that they cannot be conscious. So what level do things become conscious at then?
Well, it's more of a scale rather than
monkeys, right?
Yeah, it's a scale, not a absolute measure.
We're not as conscious.
Well, that's what I think. I think they have a dim kind of simple consciousness where, they have smells and some sort of simple...
I wouldn't even grant that.
Yeah, it's just a
Why not? Why would you? Why would you
because
suppose
you're
something
forced
else?
into you're forced into absurdities where you're saying things like chemical detectors have smells.
No, I'm saying
Yeah,
complete
you are,
living
because that's all
systems.
they do. That's
No,
like
I don't even say a dead human body is conscious, and I say that a complete
Dead.
operating system is conscious is not the same as saying that parts of that
Right, this is
system are
like
consciousness.
derailing a lot. So let's get back to the video.
Until a decision is made, and the collapsed to one state is produced, which corresponds to the intuitive way of how we think, of weighing different options before making a final decision. Second, this would also mean the information of the brain would be held together through quantum entanglement and can
What?
process and transfer information across.
Yeah, I don't know the.
Quantum entanglement?
Yeah, I don't know where he's getting. Like, let's just continue because this is just blind. Maybe he has data to present, but this is
Could have
actually.
just replaced that with blah blah blah, and it would have made just as much sense.
Okay.
When these quantum mind theories first came out, some claimed that the brain is too large and wet for quantum coherence. What this means is the
Yep.
brain contains a lot of water, and the random motion of water seems to destroy quantum coherence and produces decoherence, and thus it is claimed the brain is too wet for quantum computation to occur. But these objections are invalid for three reasons. First, the objection is based on a mathematical miscalculation. Superposition needed to be much larger than what quantum mind models predicted. And since the superposition will be much smaller, there would be less of a chance for something to interfere.
Like, on what basis is he saying this? Because this doesn't seem like. It's just sort of like mental masturbation to me. It seems a lot like. Like, I don't know where.
Heck, Mark. Is this a source?
Well, I recognize this guy's voice, okay, so I'm not going to end up agreeing with him, but I do know where it's coming from. It's a theory of Hameroff and Roger Penrose.
Yeah.
And, and there is real quantum biology. I mean, probably the most down to earth, because certainly that's speculation on neurology, though I think there's reason to investigate that. Like the photosynthesis. I don't know if you guys probably are, one is familiar.
Yeah,
So there's obviously quantum mechanics is going to play a role in biology, just like all physics, we're physical things. Anyway, he's getting it from that Penrose thing. You can see he's quoting it.
Yeah, Stuart Hameroff is just an embarrassment. I think he's just a waste of human flesh.
Oh, really? Why is that?
Because he publicly touts his theories as if they're, the best, maybe not the best, but as if they're actually coherent models that people should be taking seriously. I mean, I don't know if you've seen his back and forth with Deepak Chopra.
Oh, God.
Yeah, and then at this other conference with, I felt bad. It was Daniel Dennett, Ronald Hoffman, and Stuart Hameroff, and Hoffman and Hameroff were just, I don't even, they were just babbling, and then
but that's not his theory. These are just appearances of his where he has his own, he's not, the theory does have testable hypothesis and has to do with using, for example, he's an anesthesiologist.
Like, there's biological reasons his theory doesn't work. Quantum mind theory,
like what?
Well,
the coherence one here that IP is.
Well, that applies. That argument applies in leafs as well. So, do you believe the photosynthesis is actually using a quantum process?
Yeah, getting the electron to absorb.
So that's a room temperature thing. So obviously there are ways to isolate. You could have within a cell isolated.
Microscopic photosynthesis is not the same thing as the microscopic.
What do you mean microscopic? The photosynthesis in leaves
is macroscopic.
Right.
Yes, and the process by which the electron from the sun gets absorbed and that tiny little chemical process is microscopic.
Photosynthesis is possible due to quantum mechanical wave guiding, basically, of the photon to where it can be turned into a sugar. That happens in a leaf. That happens at room temperature.
That's like a very weird. That's like a very weird misstatement. I mean,
a misstatement? What are you talking about? Let's just go one step at a time.
Hey, this is my Hangout. You will get booted if you keep talking over people.
Okay, well, don't tell me what my misstatement was then.
It's not, the electron doesn't magically create the sugar. It's helping complete the chemical reaction.
It didn't mention an electron. The photon has to go from where it hit the leaf to where it can be turned into a sugar, right?
Yeah,
where the energy is to make a sugar.
The photon doesn't get turned into a sugar. That's not how the chemistry works.
The energy is used to make a sugar.
It's used to help it go through.
The sugar is basically a battery, right? You take the energy, you turn into something you can break into.
That's not how photosynthesis works.
No, it's a little more complicated than that. The electron triggers the Calvin cycle, and that's what causes the sugar to be formed. It happens
in the thylakoids.
So what part is the photosynthesis? I mean, is the quantum biology involved?
It helps with the electron transfer.
Exactly.
Like, you don't magically create sugar out of a photon.
Of course not. You use it as energy to synthesize a molecule that you can break up later and get some energy back, right? So my understanding of where the quantum part is in the tunneling of the photon to the center where this process you're talking about, where the sugar is actually constructed, how you get the energy from where it strikes the leaf to one of these centers in the leaf where sugars can be produced.
It goes into the excited state through the chlorophyll molecule, and then when that gets into the excited state, it emits heat and energy in the form of photon fluorescence. And then in the plant, in the photosystem, they have light harvesting complexes, and then a reaction center, and then you have the electron transport chain kind of coming afterwards.
The point is, you can have quantum guides and coherent quantum states at room temperature. In these loops, we have that.
Yes, but that's
not an argument against it being in the brain.
I know, but that is a microscopic process, and it plays a role in a macroscopic process. But that's happening at a rate that, in order for the plant to get its energy, it has to happen at an extremely fast rate. So the photon absorption level is still really high. It's the same way a laser works. The photons are microscopic, but the lasers are microscopic.
So are neurons.
Okay, but we're talking about things that operate under quantum rules, and I'm saying that a laser does the same thing, but it's a microscopic thing. But it doesn't mean that the actual effects of tunneling will apply to a macroscopic object.
What are you talking? Like, quantum mechanical stuff happens all the time at room temperature.
Yeah, I'm not arguing against that. What I'm saying is that the effects of tunneling, like, my cell phone is not going to tunnel through this house and hit you.
Right, but it has particles inside of it that are tunneling all the time. So
the point I was making is that there's a difference between the effects the tunneling effects that happen in a microscopic object and the tunneling effects happening to a macroscopic object.
Basically, what this quantum woo theory is asserting, from my understanding, is that, and what I think Polymath is trying to explain, is that they're alleging that this quantum stuff happens at a scale that it just doesn't.
Yeah.
And not that it doesn't happen. And I've not seen hard evidence that any of this stuff they're talking about in this this Penrose theory it breaks down at multiple levels, and I've not seen evidence to suggest. I mean, the most of what I see from their theory is post hoc justifications when some of their predictions actually have been falsified biologically.
Yeah.
It's not, again, like, I'll be interested in it when there's a reason, when, the literature gives me a reason to be interested in it.
Yeah.
Well, it's not that anything he says is right or wrong, it's just totally jumbled and incoherent. He just throwing big words at us.
Well, that's not true. I mean, it comes from Penrose talking about a kind of collapse that can happen, and he's the one that had the weird spiritual attitude about it. But the kind of collapse really is possible from, you know, at least the mathematics of quantum mechanics, and so they had this theory. I mean, it's not just a jumble at all, and it's not laughable. They don't have to prove their case before they investigate it. So, you know, saying that if you're going to laugh at it until they have something to prove is like, okay, so you're going to fight it and ridicule it until they prove something. It isn't a jumble. I mean, it's a theory.
I'm saying he hasn't even coherently formulated anything at all. He's just stating a bunch of trivial facts about atoms and quantum mechanics.
What do you mean he theorizes?
Okay, one of you is talking about Penrose, one of you is talking about fucking IP.
Sorry, I'm talking about IP. I didn't mean to derail the Penrose thing.
And also, you know, James, if you're,
I guess.
If you're not familiar with what Penrose believes about quantum collapses, he believes he believes in what's called an objective collapse, which means that it has something to do, his theory has something to do with once, you know, a certain, I'm forgetting what the exact formulation is, but it's basically that collapse is not, it's not due to, you know, some interaction, it's due to some actual physical perturbation to whatever fundamental particle,
he argues
and
that
it's not been experimentally proven.
No, right.
Quantum
gravity happens in It's the effects of quantum gravity in the microtubules in the brain that causes consciousness. That's absurd. We don't even have a theory of quantum gravity.
But it's not absurd to say when you're an anesthesiology researcher looking for what causes people to pass out so that they don't have to feel pain during
synchrony is one thing.
For him to theorize that you know, it's the tubulin and that there are waveguides so that you know, when they get in resonant pattern they can have this connection, and that's how it gets its processing power.
Yeah, but that's not even
not totally ridiculous, really.
That's not even the mainstream theory of how, you know, that's not even like how anesthesia, the modern understanding of how.
Well, it depends. I mean,
happens is
like. Well, it depends. I mean,
what does it depend on?
The particle theorists, for example, are now the quantum computing guys are the quantum mechanical guys because they realized if everything's doing quantum processes out there and the information is being transformed, that's what a quantum computer is going to do. And so basically their view is that the universe is made of quantum information. It's not that odd to think that a brain might be made of this kind of computer just as likely as it would be made of a Turing machine, or maybe more so since it's a more powerful computer.
You know there's more than just one theory of
like
quantum consciousness, right?
I mean, generally the way that the biochemical, you know, understanding of how things like general anesthetics work is that they have very specific targets that knock out specific channels in the brain. Like, that's generally what the mechanism of action is. Hameroff's kind of coming left of field on even that. Like, even the thing that he's supposedly an expert on, he's coming extraordinarily left of field on it. And that doesn't mean he's wrong, because I don't think there's a unified, as far as I know, there's not like some unified theory of how anesthesia works, but as far as I'm concerned, people aren't, you know, it's not, his views aren't necessarily taken terribly seriously, even on that topic, and that's the actual one where he has some certified expertise.
Yeah, he has no, I mean, he's talking about space-time geometry and ethical values at the fundamental nature of the universe. He's just...
Well, he's allowed to have his own personal opinions. That doesn't mean that's his theory, right? I mean, his theory is definitely more falsifiable than that.
Well, I mean, he should stop, you know, asking people to entertain his bullshit unless he produces some empirical evidence. That's all I'm saying, because it annoys the hell out of everybody else.
Has it been tested?
No. Well,
not really.
Then,
I mean,
then please don't call it a theory.
Oh, sorry, hypothesis.
Thank you.
Well, no, some of the things have been tested, and some people, you know, there's controversy, and like you say, you're saying, oh, they've been proven false. Well, it's his responsibility as a scientist to create falsifiable things, and as they all become falsified, or if certain tests that are taken to falsify them continue to show, he'll have to give it up or alter the theory, and that's how the theory will evolve. That's how they always evolve. So, I mean, the theory itself is not offered in anything but an ordinary academic way, and the fact that people, I mean, whatever, in the computing world, they think they're going to get consciousness just by computers getting fast enough. To me, that seems ridiculously absurd, but I don't laugh at those people like they're not scientists.
That's a huge misstatement of what's going on in the artificial intelligence community.
Oh, they don't think they're just going to suddenly get a conscious creature out of a fast enough process.
It's not about I mean, first off, this is showing your ignorance on computation, because our fastest computers compute faster than brains do. And
no,
more computations than a human brain.
Yes, it is.
No, it's not
it has to do more with the
erase a calculator.
Why aren't they already behaving?
Because it's not about. Will you let
By
me?
the way, I'm a software engineer.
Complete a sentence, or I'm going to boot you.
Well, you're rude. I'm a software engineer. Let's debate computation.
The argument in the artificial intelligence community is how to construct the proper algorithms that integrate the information correctly. That's the nature of what the debate is in the artificial intelligence.
Speed is like...
They are part of the group laughing at Hameroff because they think it is just this deterministic computation. You don't need any woo of free will somehow recovered from physics, right? And they seem to think that we will create the equivalent of a living consciousness through computation. Or do you disagree?
But it's about implementing the correct models that learn things in the way that brains learn things.
Yes, it's not only about speed.
Is actually is actually doing what brains do, right? Like, that's the issue. It's not.
Well, but what I'm talking about is this theory that you could already do problem blind, as they would say, by the fact that, as you say, we know so much about how the neuron operates, and there's some people doing this already, that you can characterize the brain, and when you have a fast enough computer to simulate the parallel processing of all of these simulated neurons, it'll be aware.
It's not about speed of processing. Like, I don't know where you're getting this from.
Yeah, supercomputers already are doing better than we can, but now it's about, like, for example, they just constructed the largest artificial neural network, and going into, things like deep learning. Like, let me just link it here.
Yeah, I mean, the question is things like, yeah, exactly, like deep learning. Like, it's how the things, like, it's been a while since we've had computers that can do more calculations per second than the brain. Like, we've had that for a while. So it's not been an issue of
non-parallel.
Yeah.
The issue is with...
You cannot simulate a brain. A computer's not fast enough to simulate all the neurons firing in a brain.
Need.
The computer cannot simulate the action of all the neurons in the brain yet.
Yeah, but that has to do with the network construction. We don't have the proper network construction of what's going on. Like, we don't have
But wait, do we know enough about a neuron to simulate it in a computer?
No, we don't know enough about any cell. Like, our simulations are good, but they're very crude.
We're improving, though. So
we're improving, but it's about the construction of the algorithms that interrelate these things. I don't know why. Like, I mean, by dint of being a software engineer, that doesn't, if you're going to use that as a claim of expertise, I'm surprised you don't know this. Like, I do
know this. I know what you're talking about. I have my own perspective, and I'm characterizing. There's a lot of different people in these fields, of course, in all cases.
Of course, yeah.
I am characterizing it a certain way because I know that this is one thing that's expected. It comes up in the debate on consciousness, is generally the computational guys that will do it just figure there is no question of whether a Turing machine can even simulate a living creature or not. It's quite possible that there's physics going on that's computationally hard and cannot be done in a Turing machine, that can be done in other kinds of physical systems, computational systems. So, as far as machine learning stuff, I used to hope you could do this. No, I think that you can easily, through induction, see that the Turing machine will never simulate the behavior of of a living creature. It just seems it might do it so that it could fool a person, but it'll all be entirely algorithmic and end up being a different process. That's what I believe from doing these things, because I use machine learning and stuff. These are all part of the data processing that I do. There's nothing there that is creative. There's nothing there that's going to simulate choices or any of these things that characterize living creatures.
It's a long way off.
Why are living creatures not algorithms?
Yeah, there seems to be an inbuilt assumption there that creatures aren't algorithmic.
Have you heard of Marvin Minsky?
Right, I have heard of him. I forget who he is at the moment. If you,
Yeah, he's an
it's
AI
familiar.
researcher. Just go Google the guy. Sometime. No.
I mean, there's really like things like speech recognition, for example. Like we can describe that very algorithmically. Like now that we have deep learning algorithms, like that's been a huge breakthrough. That's why we can do text-to-speech stuff, right? It's about creating, like what the brain is very good at is, it's not just that the brain is good at learning, the brain is good at identifying key features. Like,
right, but there's certain...
That's very tricky to encode.
But you know about complexity theory?
Yeah.
Okay, so there's certain kinds of problems that are inherently complex, that take a tremendous amount. Given a big enough set of samples, there couldn't be enough time in the universe. With computers a million times faster, they're just inherently complex for Turing machines. Some of those problems are not complex.
Don't know.
I mean,
computers. I don't think that I've never seen a problem formulation that lays out a coherent case for what measuring an algorithm of consciousness would even entail.
I'm not even talking about that. I'm just talking about quantum computing and the fact that there's certain kinds of problems that are not complex, that can be done in constant time with a quantum computer, that are in exponential time with the Turing machine. So that's a fundamental limit of Turing machines that you can't get over with algorithms, because we already know certain kinds of problems are likely unsolvable by some algorithmic cleverness.
I don't see how that relates to what we're talking about. I'm very familiar with complexity theory. I don't know what this unless you have an actual problem formulation that resembles consciousness, which I've never seen one. I don't really know why we're even having this discussion.
Oh.
Okay.
Well, I was just saying the inherent limits of Turing machines. They're not universally able to simulate everything out of physics.
Yeah,
there are problems like the traveling salesman problem that are too hard to solve in polynomial time.
Are you saying then that consciousness cannot be simulated by a Turing machine?
I believe it's not going to turn out to be simulatable by a Turing machine, yeah.
But okay. I mean, you even have a problem formulation that...
Yeah, you kind of need that.
And how would it get the internal picture? That's my question. How would it get the Cartesian theater? How would it have the subjective feeling of an emotion? It would just do the next thing like a waterfall.
Aren't you? I mean, you keep asserting, there are things that are difficult for computers to do. Okay, but the way that you prove that consciousness is like one of those things is you need two things. If you're familiar with algorithmics, you need a problem formulation, and then you need to actually reduce it to something that is that hard. That's one of the first things you learn when you're trying to reduce a problem to see whether it's polynomial time computable or not. And we're just getting non sequiturs. So I'm going to continue with this video because I'm finding this very uninteresting.
Second, the tryptophan molecules, which were proposed to be involved in quantum coherence, exist in areas of microtubules, which are hydrophobic, that is, areas which would exclude water and would protect against interference. So the water molecules cannot enter into these areas and interfere with coherence. Lastly, this objection is directly challenged by the fact that quantum coherence does seem to play a role in biological organisms, as discussed earlier, and more are being discovered. These biological organisms contain as much water as the human brain, and that doesn't seem to preclude quantum coherence from taking place. But is there any actual evidence quantum effects are taking place inside the human brain? In fact, there is. Predictions of quantum mind theory have been confirmed. Information processing has been reported to exist in microtubules, and we have experimental evidence of large-scale...
So we already discussed these articles and about how they don't actually prove anything about the brain or anything that's happening in vivo, just for the audience's sake, because it's been about 30 minutes since we had this discussion.
Quantum vibrations coming from microtubules. In 2011, evidence of topological qubits was reported to exist inside microtubules, and the same researcher recently pointed out the microtubule appears to be a fundamental information processing device in biology. Thus, if we can piece this all together, it appears we have excellent experimental evidence the brain is quantum computing.
Nope.
No, because you're talking about you're talking about subcellular structures, and then you're abstracting this to an entire, very diverse tissue. Like I don't know how it gets from A to B to Z.
This is old.
This is a textbook example, I guess, of how to make a very convoluted non sequitur.
Like, am I the only person who this is jumping out to in terms of, like, he's trying to take something that is subcellular and abstract that to it's happening in the tissue without evidence that it's actually happening?
Yeah, I don't buy it. I don't buy it.
Which, again, I'm interested if we actually do have a theory that, like I said, it's interesting if we do actually have a theory that predicts things on this level. I just don't see it as being the case. And he's not mentioning the failures that this theory has been known to have, including specific aspects of neurobiology that don't measure up.
Topological qubits appear to exist in microtubules. There is information processing inside microtubules, and there is evidence of large-scale quantum vibrations. And we have cumulative evidence.
We don't have number 3. Number 2 doesn't necessarily follow from number 1. So.
And number 1 is questionable given the theoretical nature of that whole thing.
Yeah, it's not. He's not laying out. But again, I mean, this is not how inspiring philosophy makes cases. He likes to dazzle people with fancy-sounding words that he doesn't actually look into.
Quantum mind theory. But what does this have to do with the evidence for the mind not being created by the brain?
That's a great question.
If the brain emerges from quantum computing, the same quantum rules and effects apply, and the implications of the measurement problem apply to the brain as well.
Okay. I'm waiting for the soul to come up.
The brain has several different pathways along microtubules in a quantum superposition, and we must ask, what is causing measurement and final collapse? The implications we see in quantum experiments would carry over to quantum biology.
Has he read Penrose's? Has he read Hameroff's papers? Because according to them, consciousness exists as an act of when collapse happens.
Yep.
Yeah. And it's completely contradictory to what is the fucking chain thing that he always talks about.
The von Neumann.
Von Neumann. Yeah.
Yeah. Oh my God! Don't even get me. He just. Dude, that last summer he just made it crazy for me. Just responding to his bullshit was the worst.
Then why do you keep doing it?
Well, I stopped for a while and just went to philosophy of mind. But I don't know. He's just crazy.
Well, he's just not even wrong. He's just so off the deep end of what's right.
Yeah, that's a common theme among what these people say. They're not even wrong. It's just not saying anything.
The wave function of the material brain is collapsed by the mind, or the observer.
What? Where does this come from? It's just complete non sequitur. Oh my God. I never change. I need someone to laugh at.
How many non sequiturs has this video already made?
I don't know. We've only got 2 minutes left, so let's finish.
In other words, the mind measures the brain, It produces
Oh,
real
God.
effects periodically.
What does that even mean? What? Define the word mind.
Where did the mind come from?
Yeah, this just comes way out of nowhere. I just don't know what to say. Like,
Mind measures the brain and produces real effects carried out in the brain. What is he talking
They're
about?
not separate. They're not a separate quality.
yeah, it's like we said, it's this magical thinking.
The mind is the emergent property of the brain. It's an emergent.
Yeah, I mean, all that he's laid out is actually completely coherent within an emergence framework.
And then in quantum physics or any kind of testing, the observer doesn't mean somebody watching. It's to test.
Well, but here's what makes it worse, is the theory of physics that he's using to justify this nonsense doesn't even believe in, like, the observer effect being the way that it is. Like, collapse is a function of the physical state of the electron. So, like, anything that alters, like, the quantum, like the relativistic quantum state of, because it's a quantum gravity theory that they're using, anything that alters that in some certain way causes collapse. So it's not even like an observer. It doesn't, like a conscious observer. It doesn't have to be.
Yeah, it can be any sort of physical process.
Yeah, he's positing that the mind interacts. Like, this is dualism, actually.
That's exactly what it sounds like.
Is he a dualistic idealist?
That's not even, he's making stuff up.
Yeah, I don't know.
Like a dual aspect idealist now or something like that? Because No More wanted to know what his position was, and the guy kept jumping like a kangaroo.
I mean, the sad thing is he makes a lot of money for doing these videos.
Oh, there you go. Okay.
God.
Okay, there it is. There's the answer. He makes money.
Let's try to finish this off.
The need for an observer to cause collapse. Plus,
Yeah, that's not part of the quantum mind theory. That's not part of the quantum theory you're embracing if you're embracing Orco-R. Fucking
Wait, yeah, Penrose's theory of collapse is entirely different.
Yeah.
Yeah, I agree with it. I agree.
carry over to what we discussed in the previous
Bullshit.
Plus, this experimental data correlates to exactly what we see in the neuroscientific research on mindful attention and the plasticity of the brain. The mind is able to produce real observable effects in the brain.
Yeah, you don't need to exit the brain for that. It's just an auto-regulatory loop. Like, what?
Yeah, that's what Sam Harris said. It's just the brain influencing its future states.
I mean, feedback loops are universal in biology.
It's like a...
Here's the reason why. It's because it's easy to feedback loops are inherently easier to engineer than complex regulatory systems.
It's one of those things like where the causal loop is bidirectional. Like, okay, sure, the external environment can cause changes to the brain, but changing your brain can also change your attitudes, where you can also change the external environment around you.
Yeah.
Yeah, I mean...
That's completely consistent from a physicalist point of view.
Yeah, if someone insults you, the sound waves go to your ear, get processed by your brain, and you can punch them back.
I mean, but even deeper than that, you take any sort of network biology course, you talk about these things. This is not something that is really left of field. The idea that feedback loops exist in biology and they're very common. You can engineer them into E. coli so that you can get E. coli that express a fluorescent protein in different patterns.
Technically, I know you know a little bit more about epigenetics, Sam, but couldn't the same concept apply to genes? The external environment has an effect on which genes are expressed, and hey, those genes that are expressed also affect the external environment as well. It's
that's how the cell cycle works.
Yeah,
exactly.
That's exactly what it does.
Exactly what the cell cycle does.
Hold on.
It's just these coordinated coordinated regulatory feedback loops. That's all it is, right? It's all it's all orchestrated in this really it's an incredibly complex thing that arises out of fairly simple signals.
I think the whole, and this also says a little something else. Like, I'm surprised he wouldn't use that argument, like, for genetics as well. Like, ooh, like, the environment is changing the genes and stuff. I think he definitely wanna go more exploiting the whole idea of, like, it being related to neurology because, neural networks are a little bit more complex than genetic networks. So, it gives him more room for woo. If anything of what I just said sort of makes sense.
Yeah, but I mean, you're asking him to actually, like, you have to realize that he has no desire to actually understand these things. But that's a fundamental thing that you've got to understand, and that's why I don't get frustrated with him.
Yeah, just take it in stride.
Just finish the goddamn video. I'm sick of this shit already.
On top of that, this has even been shown to produce effects and changes in the body, giving new meaning to the term placebo effect. Studies on cancer patients show mindful attention can not only produce real measurable changes in the body, but also in our DNA. It appears we are not slaves to biology or our DNA.
That sounds like bullshit.
My dad's an oncologist, for the record, so, if you have cancer cures, like, if it's really just mindful attention and just being happy, I would love to hear about that.
Yep, I'm gonna bookmark this article.
I actually am doing my thesis on targeted delivery systems, so yeah, that would be really cool if we could just mindful it away.
So he's saying you can wish yourself a tail.
Like, mindfulness is actually associated with telomere length, but this isn't. You're not. But like, this has been associated with, like, when you reduce stress, like, your telomerase can get reactivated so that your telomeres don't shorten as much.
You sounded like you blue screened in the middle of saying that.
Or
like Ira.
I was thinking out loud. Sorry. No, I mean, this is known. Like, it's not. You're not literally changing the DNA. You're changing the expression of an enzyme called telomerase, and, like, mindfulness has been shown to increase the expression of this enzyme, and this enzyme keeps the telomeres, which are sort of the ends of the DNA, it keeps them regenerated, and this has a protective effect on the rest of the genome, and so telomere length is associated with lifespan, as an example.
Yeah.
Like, again, this is why I hate popular science, because that's not. God damn it.
Oh yeah, no, I know exactly. Because the big issue, like, with a lot of these popular science articles, is you hear what they're saying, like, in the article, and they sort of reference sometimes a study that was done by the university professors. Then you actually read parts of the paper or read the whole thing if you want, and you're not like, wait a minute, this doesn't sound exactly what I saw in the shorted popular science version.
Well, it's like the worst is when they explain how a trait is heritable, and then people don't know what heritability means on a mathematical level, and so they'll be like, oh my god, this is all heritable. And it's like, that's not, like, the way that you're using that word is not the way that the scientists do. Like, you just have no fucking clue what you're talking about. And it's really, this is another example of that.
1 minute to go. We can do it.
But active participants in the outcome. That obviously doesn't mean we have godlike control over ourselves, but the evidence still indicates we are participants, not totally determined by biology and genetics. The old notion we simply dance.
A biological system is being mindful of itself and inducing biological changes.
It's the secret.
Who even argues that we're, like, completely controlled by our biology and genetics anymore?
Let's just continue.
Wait. No, I was just gonna say it's a weakened version of The Secret. It's The Secret Light.
Has been experimentally challenged and found to be lacking. Therefore, the evidence demonstrates the mind is a real and active force, necessary to collapse the wave function of the brain and produce real changes.
No, how did you demonstrate that? Like, you did not demonstrate that. You just asserted it. Like, what?
Yeah.
This fucking asshole.
So does the brain exist in a superposition of states?
Your brain got a quantum object IP. That's why this doesn't work. Good Lord.
Fucking idiot. Jesus Christ.
Quantum biology is still in its infancy stages. More experiments are needed for more accurate conclusions, but the writing is on the wall, and the way we view ourselves will forever be changed. And if the quantum nature of reality is not only true about ourselves, but the world around us, a new picture of reality emerges, turning the old materialist notions on their head. We are not soulless zombies dancing to our DNA, but real and active beings. As we said before, the old Cartesian notion of the ghost of the machine may be dead, not because there is no ghost, but because there is no machine.
God damn it. This guy is a fucking moron. Like, it's not just me that he just leapt into this non sequitur headlong.
No, he didn't even wear a helmet when he did it either.